Okay, so hello everybody. Tonight we will be doing simple trig proofs, and let's go ahead and begin. So the first one we have here is sec x minus tan x sin x is equal to 1 upon sec x. Now when doing a proof, first thing you want to do is identify the more complex side, which is the left hand side, and start with that one. So we have sec x minus tan x sine x. Now you want to look at what you're trying to get and see how you're gonna get there. Now we have 1 upon sec x over here, and then we have a sec x here, but we want to get 1 over sec x. Now we can try to relate sec x to something else, and we can do that by saying 1 upon sec x equal to cos x. This means that if we can get cos x here, we can get 1 upon sec x like we have on the right hand side. So let's go ahead and expand this to get cos x into the equation. So we can replace sec x as 1 over cos x and minus sine x over cos x times sine x. This now becomes sine squared x over cos x. Of course, that's being subtracted from 1 over cos x. Use cos x as the LCM. Cos goes one time, so we got 1 here. That goes 1 time. 1 times sine squared x equals sine squared x. So that's what we have. Now, as you know, 1 minus sine squared x is equal to cos squared x. Therefore, we can rewrite this as cos squared x over cos x, which would be equal to cos x, and as you know, cos x is equal to 1 over sec x. Therefore, the left hand side equals the right hand side. Next one. Now here we have 1 plus cos x over sin x is equal to sec x plus cot x. Now we will go ahead and start with left hand side again. Now on left hand side we see we have 1 term, but on the right hand side we have 2 terms. So the first move here would be to go ahead and split this into 2 different terms. We can write that as 1 over sin x plus cos x over sin x. Now of course we know that 1 upon sin is equal to cosec. Therefore 1 upon sin x we know is equal to cosec x. So we have that part. Next part is cos x over sin x. Now as we know, cot x is equal to 1 upon tan x, and tan x is equal to sine over cos. So this becomes 1 over sine over cos, which becomes cos x over sin x. So therefore cot x is equal to cos x over sin x, and so this part here, cos x over sin x, becomes equal to cot x, which means this whole thing can be rewritten as cosec x plus cot x, which is what we have on the right hand side. Next one, cos squared y minus sine squared y equal to 1 minus 2 sine squared y. Now we have cos and sine on the left hand side, we have just sine on the right hand side. So we can go ahead and start with the left hand side and try to get the cos equal to sine somehow. As you know from the identity, sine squared theta plus cos squared theta equals 1. Cos squared y would be equal to 1 minus sine squared y. Then you would minus sine squared y. First, 1 minus sine squared y minus sine squared y would be 1 minus 2 sine squared y, which is what we have here. And the final proof. Now this one is the most complex, so pay attention. Now we have sec theta over cos theta minus tan theta over cot theta is equal to 1. The best way to go about this is to reduce the more complex identities to their simpler forms. So we can put sec in terms of cos and cot in terms of tan. So we can go ahead and rewrite this as 1 over cos theta, which as you know is equal to sec theta, divided by cos theta, and we can go ahead and put it over 1, and then we can see minus tan theta, we're going to put that over 1, divided by 1 upon tan theta. So as you know, cot theta is equal to 1 upon tan theta. Now, the rule of dividing fractions is keep, switch, flip. Keep the first term, switch this to multiplication sign, and reciprocate this. Therefore, we have 1 over cos theta times 1 over cos theta minus tan theta over 1 times tan theta over 1. So we have 1 upon cos squared theta minus tan squared theta all over 1. And we can change tan squared theta to tan squared theta or over 1 to sin squared theta over cos squared theta. As you know, tan equal to sin over cos. So we can say 1 over cos squared theta minus sin squared theta over cos squared theta. And of course now we can just subtract with cos squared theta as the LCM. Into this goes 1 time, 1 times 1 is 1, so we have 1. Cos squared theta goes into cos squared theta 1 times 1 times sin squared theta. That gives us back sin squared theta. As you know, 1 minus sin squared theta is equal to cos squared theta. Therefore, we have cos squared theta over cos squared theta, which is equal to 1, which is the right hand side.